Okay, here we are looking at exponential growth through the eyes of a $2,000 investment in a bank that's compounding this interest every year. So each year, 1 year after your investment, you get your 5% interest. How much will be in the account after 10 years? Okay. So before we start, just a couple little basic things. One is that when we are adding some quantity over and over and over again, I'll just stop at 3, we get a simple multiplier times that quantity. But if we are not adding but multiplying that quantity multiple times, we get x to the third power. Okay, so this is really what exponential growth is all about when you're multiplying over and over and over again by an amount. So in this case, if we say, all right, I think most of you know how to find 5% of 2,000. We take that amount and we simply multiply it by 0.05. That's the decimal equivalent of 5%. We move the decimal place 2 places over. This would tell us the actual interest. In this case, it would be $100. If you take your calculator out or if you multiply it out, you get 100. But that's only the interest. And of course, if you go to the bank, you're going to get back your original investment plus the interest. So we'd add on to that $2,000 plus that interest. So really our original expression would have been 2,000 plus the 2,000 times the interest. Okay? So what we can think of is then is if we factor out the $2,000, right? So factoring is pretty standard. If we have 500 minus 50x, right? You know this, that we can take and pull out the 50 and write 50 times 10 minus x. Okay, so that's in factored form. If I pull out the 2,000, I will have this be 2,000 times, and then when I take 2,000 out of 2,000, it's by division, so it's 1 plus 0.05. All right? Well, that's nothing more than just do that addition. So that's 2,000 times 1.05. So I could have found my answer that way from the very beginning if I thought of it that way. Well, we're going to do this. This is after only 1 year, so we're going to do this multiple years. So you take your $2,100 the next year, and you're going to do the same thing. You're going to multiply this by 0.05. And you'll get, in this case, if you do the math, I think you'd get 2205. All right? So that would be how much money you'd have at the end of the second year. And then to find it at the end of the third year, you take your 2205 and you'd again multiply it by 1.05. Because each time we keep the original amount and we add on to it our 5% interest. Well, if you think about how we found this, we can take and substitute this in down there, and we can take and substitute what this gave us right here. So really, this year, I could say is the same as $2,000 times this first 1.05 times this second 1.05 and then times this third 1.05, and that would give us the answer for after 3 years. Well, this is nothing more than what I just set you up with at the beginning. We've got repeated multiplication, so I can say this is equal to 2,000 times 1.05 to the third. All right? Well, if we're going to go up to 10 years, what do you suppose changes? Pause, think about it, come back, and yeah, that is going to go up to 10. So all we're doing is we're multiplying 1.05 times itself 10 times, and then that times 2,000. So you can take a calculator, and we can type that in. See if I can show it here. I think it's a little bit hard, but maybe possible. Turn that on, and you can see right there, hopefully, it's not too out of focus, you get $3,257 and about 80 cents. All right? So that's the way you can do that, by putting as a general formula your principal, your original investment, the amount of money you have after time is going to be the original, the principal, and then 1 plus whatever the interest rate is as a decimal, and then to the t power. Okay? So that's where that equation comes from. That will give us the value after a certain number of years. Well, it doesn't just have to be money growing. We also have what's called exponential decay, and that is when something is losing value at a certain percent. All right? So to change this around just a little bit, let's say that a $20,000 car, all right, is purchased. Purchased. That loses, it depreciates 5% of its value. Okay? Loses 5% of its value every year. How much is the car worth in, let's say, I don't know, 15 years? Okay? So your car is losing 5% of its value every year. It's the same type of thing. We say, okay, we've got a $20,000 car, and it's at 1 minus 0.05 for X number of years, in this case 15 years. And so we just simply do the math here. 1 minus 0.05 would be 20,000 times 0.95, and then to the 15th. And you can type that into your calculator and see what that would be worth. Right? If it said something like, well, how long until the car is worth some value that you determine, I don't know. Let's say our car goes from 20,000 down to 10,000. The car is worth 10,000, 10K, that's shortcut for 10,000. How long will that take? Well, then what you do is, and I'm going to grab the camera here. Apologies, don't want to make you seasick. But if we put in the equation here, $20,000 times 0.95 times a variable x, and then we graph it, you're going to see that here's the value of the car going down. Okay, now the tricky thing is setting the window. So look at this. X is our horizontal variable. This is the years you might own a car, and I'm just showing from -2 up to 30. The -2 allows you to see the actual vertical y-axis, so that's kind of handy. You could make that 0, but cars aren't usually owned for more than about 30 years. And then the value of the car, again, I want to just see that horizontal axis, so I've gone into a little bit of negative territory. 1,000 might seem like a lot, but remember, our car value is 20,000, so I'm going up a little bit above 22,000. And then this is just where our little ticky marks are on the scale, so that's not a big deal. So there's our graph in the window. This is from 0 to 30 years. This is from about 0 up to about 20,000. So how long will it take to get to be 10,000? I go back to this. I've typed it in already. I just need to turn that axis on. And now when we graph it, I can see there's my $10,000 value. And if I do trace, I can just move it along until it gets to there. Or I can do second trace and find the intersect point. That's 5. And I just hit enter, enter, enter. And it'll tell me, oh, that's exactly after 13.51 years. Okay? That should be enough to get you started on that worksheet. Good luck.